Alright guys, so I already did this one right, and then I got into the video and I did this one wrong, and I did all that work and I forgot about the dang negative. So look, I flipped my spinner. We'll talk about that one in a minute, but I took my spinner, which was 3, flipped it right there, which is 315 degrees, 7 times 45, and then I stopped, just totally charfed on the negative, and then I found all these answers that match this point. And nope, and there's my rectangular for this, no. So I'm going to erase that. We'll talk about this. Be back in a second. Okay, so I'm pretty confident I'll be able to explain this one without redoing it. But my spinner's 2. I didn't like how small this was, so I moved it over here. Moved it up pi over 6, which is 30. You can see it went boop. And then the instructions are kind of interesting, though. It says create 3 other equivalent polar ways. So that means r theta, and it doesn't say that you have to include a negative r, but I'm going to show you one anyways because it's good practice. Then state the coordinates of the rectangular form. So look, if my spinner's 2, which they say it is, flip it 30, my reference angle is 30, so I have a 30, 60, 90. Opposite's 1, hypotenuse is 2, side opposite to 60 is this. So my rectangular is the square root of 3, 1. That's right here. So what I did first is I said, okay, let's go for the negative r, even though they're not forcing us to do that. So yes, this is 2. And yes, I flipped it 210, 180 plus 30. But if I left it without the negative, it would stay right here. So I got to put a negative on the 2 and create 210. That's 7 times 30. So 210. Pi over 6 is 30. Okay, so we took care of the negative r, even though they didn't tell us we had to include one. So how else do we get there? Well, we can get there by going 360 plus another 30. That would be this. Now I did the calculations. So that's 390. 360 plus another 30 would be 390. And that turns out to be 13 times 30. And so you'd write it 13 pi over 6. If they require radians, you can write 390 if they don't require radians. They didn't say to put it in radian form, so we're kind of free there, but it's good practice. Then the other choice I made was to go the opposite direction. So here's my spinner, it's 2. I'm going to flip it 330 this way, negative, which is equivalent to negative 11 times 30, negative 330. So there's my answers for 7a. Now let's try to do this one correctly this time. So I've got my spinner, it's 3. So there it is. I'll erase that in a minute. I go 7 pi over 4, which is 315, and stop. But then that negative throws me over here. So I know this is 315 to here, leaving me with 45. Vertical angles, that has to be 45. And so now I know my spinner is 3. So they're forcing us into that. It's not a nice, neat number. But you just got to dummy it down. X square root of 2. We'd multiply that by the square root of 2, so we have to divide to get back. So we divide to get back. Get that radical out of the basement. 3 square root of 2 over 2. What I'm doing is finding my rectangular coordinate first. And these have to match. So this would be negative 3 square root of 2 over 2. Here's my x, here's my y. So my rectangular would be negative 3 square root of 2 over 2. 3 square root of 2 over 2. Okay, rectangular, check in the box. Now we got to figure out how to get to this position 3 other ways. Well, the first one had a negative, so why don't we change it up and put a positive and then realize this is 135. And if they force us to use radians, that's 345s. So these are the same answers. I don't think it counts as 2. It's just 1. So then the other way would be to go negative that distance. That'd be 180 plus 45 is 225. So it's still positive spinner. I'm just going negative 225. Now how many 45s is that? Well, it's 1, 2, 3, 4, 5 45s in the negative direction. Now technically we could stop. I think if that hold up in court, but you could go positive 135. Now it's just a pain. Let's do that. So we know this is going to go 135 plus a whole nother spin, and that'd be what would that be? 495. So to go all the way around would be 8 pi over 4s, 9, 10, 11 pi over 4s. All right, so yeah, we have exhausted that problem completely. State the polar coordinates. Remember, there's going to be 2 of this. Well, they're setting us up for a nice, neat 30, 60, 90. So that's -3. This is up quite a bit more if you did the math, because that's 3 times 1.7. So I know this, bad drawing, 60, 30, because I multiply that by the square root of 3 to get that. Negative, positive. I double this to get the hypotenuse. So that'd be 6. Your hypotenuse is never negative. Now how did I get there? Well, one way I got there would be with a positive r, 6, and I spun it 120, which is just 6 and then 2 60s, so 2 pi over 3. So that's one way. The other way would be to spin our spinner. You could go negative. You could do that. So let's do that. Again, this is pretty bad drawing, but if this came through like this, oh boy, this is terrible. Yeah, we got to get the negative though, so it's going to be -6. We just have to figure out how to spin our spinner to get there. Well, if this is 60, that's 60, but my drawing's terrible. So that'd be -60 or negative pi over 3. So that's one other way of getting it. So, convert the following rectangular, x's and y's, to polar. That means correct polar form means r equals stuff. Golden rule. Also, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared. So here's our rectangular stuff, and here's our polar stuff. Well, I can see this x squared, y squared just begging me to look at it, so I'm going to add 2x squared, just kind of gather it, because I'm lining up to try to create this. So I get 6x, don't care about that right now, 2x squared plus 2y squared. How do I create x squared plus y squared? Factor a 2 out. You had to be a little creative there. And now I'm ready to do some substitution. So 6x is just 6r cosine theta equals 2r squared. So what I'm going to do is subtract 6r cosine theta. We might be done, but I'm going to just keep going. -6r cosine theta. So I get 0 is 2r squared minus 6r cosine theta. 0 equals, I'm going to go ahead and take a 2r out because I can. And then I get r minus 3 cosine theta. Yeah, we weren't done over here. This is our golden rule, and it's working out. So remember our rule, r cannot equal 0, which strangely gets rid of this. So we're just going to add 3 cosine theta to both sides. Flip it around. And done. Took a little creativity. I think that was the hard one. This one they're taking it easy on you. 5 times x is 5r cosine theta minus 3y is 3r sine theta equals -2. Factor an r out, I get this craziness, but it happens sometimes. And I'm just going to divide by all of this so it cancels, and then I'm going to divide by it over here, show my work over here. So that's what r equals. R equals that. There's no way you're messing with that. You're donezos. Okay, this says convert the following polar to rectangular, correct graphing form. That's a little strange, but we'll deal with it. So, we need an r here, and we're not afraid of an r squared, so we're going to multiply this by r. You guys have done a few of these. 2r sine theta. And now we can substitute. X squared plus y squared equals 2y, using our formula up there. And I'm not sure what they are saying about correct graphing form. If it's multiple choice and they have this, obviously you check that box. But if they're saying correct graphing form, they might be saying you ain't done yet and you need to keep going. So take half of that, it's -1 squared, because I can see this is a circle, 1. Then I have to add a 1 over there. So x squared plus y minus 1 squared equals 1. Now I can tell the center is at 0, up 1, radius 1, so I could graph it if they wanted me to. Okay, so now let's go to letter B. Well, kind of like this one, said we're done. Over here, we're not done. We need to somehow introduce x's and y's. We got to get rid of this. So we're going to multiply by it and hope the other side just works out, which you just have to trust that it does. So this hits this, and then this hits this. So over on this side, they cancel. But then over here, I get r sine theta plus 4r cosine theta equals 5. So this is just, looking at the old formula, this is just y plus 4x equals 5. Now, graphing form, maybe they want it in y equals mx plus b, I don't know. But these are ready to be graphed, regardless of how you look at them. Keep going. Make a table and graph the following polar equations. What's the smallest interval for theta that will produce a complete graph? All right, one of these crazy problems where we got to find out what kind of polar graph we end up with here. And I'm just going to make sure you know how to PEMDAS these, so, and then I'll just fill the rest in. So sine of theta is what you have to do first, then multiply it by -4 to find r. So we're just going to start with 0, and we're going to go sine. Now because we have degrees, we better check our calculator, make sure we're in degree mode, and we are, but you better check that because that'd be crazy. And so sine of 0, enter, and then we multiply that by -4, we're just going to get 0. I'll do one more. So sine of 30 we know is 1/2, but we got to multiply that by -4, so that'd be -2. I'm going to go ahead and hammer a bunch of these out, and I'll be right back. Okay, so I'm just going to plot a few of these and just talk about it. Typed them all in, got these answers. You can see a pattern here, all negative r's, then the positive r's come, and then the negatives start up again. 390 is the same thing as 30. As far as the calculator is concerned, you can see it starting to repeat the pattern. I had this thought, remember sine, the sine wave, the normal sine wave, 1, -1, but the period is from pi to -pi, that's 360, or 2 pi, normal period. So that's kind of the smallest interval that just kind of comes out, it just gets flushed out here. But let's plot a couple, and then I won't bore you, I'll plot them all, and then we'll talk. So 0, 0 just starts right here. So we have another r that's 2, so it's out to here, right out to here. Flip it 30, but then we have to go the opposite direction, back to 2. And 60, -3.5, so we think 3.5. We go all the way up to 60, but because r is negative, we got to come back to 3.5, 1, 2, 3.5. So 4, 1, 2, 3, 4, up to 90, back to the other side, and then you can kind of see what happens. 120, 3.5, so 1, 2, 3.5. 120 would be 90 plus 30, And then we have to go to 3.5 this way. Did I stay on that same line? Yeah, 1, 2, 3.5. And then this is just going to match over here. Whoa. Over, boy, 1, 2, it's dangerous, 1, 2. And you can see, it goes like this and like that for all these negatives. And then we get to 180, and the R is 0, so it just stays right here. And then we got an R2, so we go 2, we go 210. So there's 180 plus 30, and it stops right there. So really, the interval needed was only 180, because it starts repeating itself. So my little theory here is wrong, but it's a thought I had. Okay, and we'll jump down to this one. These just take a while. All right, we're just going to end that one at 15 minutes. That's a good amount of time, 16 minutes, and we'll call that one good, call that part 3.